Today's lesson will be looking at Chemistry 1502. We are still busy with reactions, SN2, Nucleophilic substitution reaction, practice questions, lesson 103. Let us start. As we do these examples, we'll also be considering the manner in which we should represent the mechanism that is actually acceptable in SN2 reactions. So you're going to start with the most simplest representation or orientation of this mechanism, and as you continue we'll be looking at those concepts which are very important. Remember that when it comes to organic chemistry, it's not like the Chemistry 1501 whereby we can draw Lewis dot diagram the way we want. We have important concepts that we need to consider, or guidelines we need to consider when drawing Lewis dot diagram and reactions in organic chemistry. So the first one, we are going to look at bromoethane reacting with sodium acetylide. So we have CH3 CH2Br reacting with sodium acetylide, which is NaC2H. So we need to write down the SN2 mechanism for this particular reaction. It is very important for you to know how to draw Lewis dot diagrams. So we have our CH3 here and CH2 and Br. Plus, you can see that this will form sodium reacting with carbon, having a triple bond with another carbon and hydrogen. So you can clearly see that our sodium will have a partially positive charge, or will have a positive charge, and then this compound means that you will have a negative charge. And then looking at our substrate, we can see that the leaving group will have a partially negative charge, and then our electrophile will have a partially positive charge. So meaning that this will be our nucleophile. So in this case, our nucleophile will attack the electrophile from the back, and then the leaving group will actually leave with its pair of electron. It will leave as a halide ion, meaning that we'll be having this part remains the same, and then we have we can put our C triple bond CH here. Plus, if this Br leaves as a halide ion, it will actually bond with this sodium, resulting into sodium bromide. So this is the SN2 mechanism. Our first example. Let us go to the second one. Our second example is R2 bromopentane. Now there is a lesson video that explains the R and S configuration in organic chemistry, whereby we talk about this R. What is the meaning of this R? The meaning of S. It has to do with the orientation of our Lewis structure. We have clockwise and anti-clockwise. So there is a lesson video that explains this in detail, and also practice questions whereby we look at more examples of this R and S configuration. So you're looking at R2 bromopentane. Now we have to react it with potassium cyanide. And then we have to convert this into a Lewis structure. So drawing this, we are going to have 2, 3, 4, 5. And then we have our bromine here. And then we have our hydrogen here. It's at the back. Remember that when it's like this, it simply means that this Br is towards or in the front, and then when we have dashes lines like this, it simply means that this hydrogen is at the back. So we react it with potassium. We know that potassium is positive and cyanide will have to be negative. So we have our leaving group as Br. This is the substrate, and then this will be our nucleophile. So this simply means that our cyanide ion will attack it from the back. If this is the front, it simply means that it will attack it from the back, meaning that where hydrogen is, it will attack it from that direction. And then we are going to have then we have to represent also, then we can just represent also the lone pairs here. So if Br leaves with a pair of electrons, we can say it undergoes hydrolysis, bond fusion, and then if this Cn minus, it attacks from the direction of hydrogen, it simply means that we are going to have Cn as a substance at the back, and then we are going to have our hydrogen here, and then plus this Br, our leaving group, will leave with a pair of electron. This bond pair of electron will leave with bromine with a negative charge, forming a halide ion. It will react with this potassium. So we are going to have potassium here. Then we can just remove this this negative charge here. Let's look at this reaction. While looking at this reaction, I want you to take note of the representation that I'm using here. So we start by labeling this will be our substrate, and then we know that we cannot actually refer this to, it will be the nucleophile, but only iodine will take part of the attacking and the replacement of our leaving group. By the way, this will be our leaving group. You should know that Br is one of those good nucleophiles. So if you have, let's say, a compound, a substrate that consists of Br and another halogen, you should know that Br will be considered as our leaving group. So here we are going to have sodium with a positive charge, and we are going to have our iodine with a negative charge. You should know that iodine will have lone pairs. So if you take it out from sodium, we are going to have iodine like this, which will be our nucleophile. So you can see that our leaving group is at the back, so it cannot attack from the back. So what will happen is that Br will leave the substrate. At the same time, our iodide ion, it will attack from the front. Then we are going to have nothing happened to this part. So we are still going to have CH3, our hydrogen there, CH3, CH2. Orientation will change. Remember that we no longer have this at the back. Then it means that if iodide ion attacks from the front, it means that it will take the position of anything that is at the front. So in this case, our hydrogen will no longer be there, will be at the back. And then the front, we have our iodide ion, and then we still have our CH3 there. Plus, our leaving group will bond with sodium, then we have sodium, Br. Sodium bromide, by the way. I hope you can see how we replace this. And it's very important to know how we replace. If it attacks from the front, it will take the position of the front atom, and then the one that was at the front, it will be at the back. This will have to do with the trans and the cis, which is CIS. But there is another lesson video that describes that in detail. You can go ahead and pause the video, play the video to verify the answer. This is our substrate. Then remember I said Br is a very good leaving group. So here we are going to consider Br as our leaving group, not fluorine. Fluorine is a poor leaving group. There will be a lesson video whereby we'll be looking at the range and also the rank of good leaving groups and also good nukes, or let me say nucleophiles. So in this case, we know that as usual sodium will have a positive, then it means that this we are going to have it as a negative, and then this will be our nucleophile. This is the leaving group. So what will happen is that it cannot attack from the top, but it will attack from the bottom. And you should understand that there is no atom at the bottom. This one is going at the back, then this one is at the front, this one is just at the opposite direction. Something like this, whereby this is towards the page, this is going inwards the page, and then this is at this direction. So here we do have a space whereby our nucleophile will have to attack. So it's not going to replace anything. So as our leaving group leaves, and then we have our nucleophile attacking at the back, then it will result into something like this. I hope you can see. Let us look at this. This is the substrate. This will be our leaving group. And then our nucleophile is actually here. But we're going to have our sodium as a positive. And then this will actually be a negative. It will be the nucleophile that will take place in the reaction. So what will happen is that we can see that our leaving group is at the back. Then it means that our nucleophile will attack from the front. So meaning that whatever atom that is at the front will be replaced by our nucleophile. And then the atom that is at the front will take the position to actually go to the back. This has to do with the invasion configuration, but there is a lesson video whereby we talk about that. The reason why I made lesson videos parts by parts so that you don't get confused. In this lesson video, we are just focusing mainly on the SN2 reaction. It's very important for you to be able to identify the nucleophile, the substrate, the living group. So as it attacks, the living group will leave the substrate. And then the results, we are going to have our nucleophile that has replaced the living group and our hydrogen here, and then the living group will bond with our sodium here, so we are going to have sodium bromide. Our next example is a bit different from everything that we've learned or all the examples that we've went through so far, but I want you to be open-minded. There is nothing difficult here. Remember that what is important, be able to identify the substrates, the nucleophile. This will be the substrate, this will be the living group. We can go ahead and put the lone pairs, and then this as a whole will be the nucleophile. Remember that we cannot separate this somehow into two parts, but in order for us to actually use this as the nucleophile for explanation purposes, let us draw the Lewis diagram of ammonia. So ammonia is one of those nucleophiles that they will take part in the reaction as a whole. So when you draw it, the Lewis diagram, we are going to have something like this with two lone pairs. In this case, these two lone pairs will be the ones to attack the electrophile using those two lone pairs. And also bear in mind that if nitrogen bonds 3 times, it will have a formal charge of 0 with these electrons. If it bonds 2 times, it will have 2 lone pairs with a negative charge. If it bonds 4 times, it will not have any lone pairs, but it will have a formal charge of positive. So in this case, let us go ahead and do the SN2 mechanism or reaction. So you can see that our living group is at the front, meaning that our nucleophile cannot attack from the front, but instead it will attack from the back. So attacking from the back, we look at the atom which is at the back. You can see we have D here. So it will actually replace the position of D. Anything that is at the back will be replaced. So we can say this nucleophile will attack with these electrons from the back, and then our living group will also leave with those bonding electrons. Then we are going to have our product, our D will be at the front, and then we have our H here, and then at the back we are going to have our nucleophile. But remember, I said if nitrogen bonds 4 times, it will have a formal charge of positive. This reaction, like I said, it will be a bit different with the other ones. And then remember that our living group will be here. It left as a highlight ion. There are lesson videos based on formal charges whereby we explain how we get these formal charges, also the calculation, also the guidelines and tips in which you can quickly predict or determine the formal charge of these ions, and the nitrogen was one of the elements that we've went through. So in this case, we just want to get rid of this positive. By doing so, we are going to take this hydrogen, these electrons, this bonding electrons with one of the hydrogens between nitrogen and hydrogen will actually bond nitrogen, and then it's like we have another reaction whereby hydrogen, one of the hydrogens, will leave in a manner of the leaving group, but it doesn't leave with a pair of electrons. If it leaves by donating, or nitrogen having these two electrons which have bonded between this hydrogen and nitrogen, then it means that we are going to have, I want us to take it step by step. We are going to have something like this. Hydrogen lost its electron, then it will have a positive charge. So we are going to have something like this, the reaction that I've just explained here. The two electrons which are bonding nitrogen and hydrogen will be taken by nitrogen, and then as a result we are going to have something like this. And then this whole thing, we consider it as a unit. We are going to react this with another ammonia, the very same nucleophile that we have here, which is this one. We react it again with this, but since I've taken it step by step, when we write this or when we answer this, provided we're given these two reactants, then we have to represent the SN2 reaction. Start by writing this and show the movement of electrons, and then you come here as a product, but this will not be the final step or the final product. You'll have to say plus NH3. But what I've done here, for the sake of explanation, I've just shown you that once we take this hydrogen, pair of electrons, they go to nitrogen, we are going to have something like this. And then this reacted with nitrogen is the very same step that we have here, which is the whole thing here. So we can conclude that whenever we have ammonia as our nucleophile, this step is very much necessary, because we are going to have, definitely going to have this here. And once we react our substrate with the ammonia as our nucleophile, we are going to have this positive here. Then you go ahead and take the electrons which are bonding nitrogen and hydrogen, you take them to nitrogen, so that we are going to have hydrogen which is positively charged, and then we react it with the very same nucleophile we had on the first step, which is ammonia. And then this ammonia will react with this hydrogen to form NH4. We know very well that NH4 is positive. It's another polyatomic ion we've learned in chemistry 1501. And then this polyatomic ion will react with our leaving group, which is chlorine, to form NH4Cl, ammonium chloride. So we can say the product as a whole, it will be like this. We have our D here, then here we have NH2, weight is very important to represent that it attacked from the back, and then we have our hydrogen here plus NH4 Cl. Well, that's it for this lesson video. In the next lesson video, we'll be looking at more practice questions as we cover more concepts. The concept of the replacing of the atom which is at the back or the front is the phenomenon from the stereochemistry. So in the next lesson video, we'll be dealing with more examples where we explain this stereochemistry reaction in SN2. This is Wabula SJ. Thank you very much.